Can start already, Okay.
Yeah, okay.
Good days. Today we are going to do the presentation for the air conditioning and mechanical ventilations. Let me go through on the agenda that we're going to present. We will do the introduction of the ETTV, including the ETTV components, important and impact of ETTV, and then the way to reduce the ETTV, also the ETTV formula and the calculation example with the conclusion. And let me introduce our group members. We have Imagines, we have Wei Feng, we have Rozaimi, me, myself, Varish, and we have Shuku. Okay, let's start on the envelope thermal transfer value. Short form is ETTV. Let me introduce what is the envelope thermal transfer value ETTV. Actually, this is to measure of average heat gain through the external wall enclosing the air conditioning spaces in the non-resi building. So the unit used for the ETTV, right, is we are using the watt per meter square. So for the purpose of energy conservation, it's based on the BCA standard. The maximum permissible ETTV have been set on the 50 watt per meter square. All the reference can be found from the BCA. And then I would like to pass it to my friend Rozaimi to continue on the next slide.
Hi everyone. So quote on envelope thermal performance for buildings. To ensure that the envelopes of air-conditioned buildings are sufficiently insulated, the concepts of envelope thermal transfer value (ETTV), roof thermal transfer value (RTTV), and lastly, residential envelope transmitters value (RETV) were introduced. ETTV components. Three basic elements of heat gain through the external walls windows of a building: heat conduction through walls, heat conduction through glass windows, and solar radiation through glass windows. Why is ETTV important? It reduces cooling load, improves energy efficiency, enhances thermal comfort, mandatory requirement in Singapore BCA Green Mark, helps achieve sustainable building design. The impact on energy consumption. Lower ETTV is lower ACMV energy use. It reduces operating costs, better occupant comfort, and supports sustainability goals. I pass on my colleague, Imagine.
Thank you, Rozaimi. Okay, so first step to calculating of ETTV involves wall to window ratio, which is the WWR. So basically, this is a formula of the fenestration area over the gross area of the exterior wall, which you can see as the example as follows, which gives us as 0.2 here. Next. Secondly, there's a way to reduce the solar heat gain. So one of the ways is actually shading coefficient, which is the external shading, as you can see that which we can find in the HDB blocks. And secondly is the tinted of the windows. And both these are actually the first line of defense against solar heat gain. So both of these calculation is shown as below, assuming that 0.8 and 0.7. So both of these times together and we get the total shading coefficient can be used for the calculations later on. Next. So example application of this shading is actually widely used in HDB blocks and also in office buildings facade, like you see in the picture below. They actually uses tinted glasses and shading films. So as a result, lower cooling load and also energy saving consumption. Next. Third one is actually is thermal transmission or the view value. It's actually calculating the average thermal transmittance through the concrete wall from the outdoor. So basically, this is a formula to find the average view value, which is X over K. X represent as the material used. As you can see here, it's the example of cement, plaster, and also concrete. And K is the thickness of the individual material in mm. And once you got the RT or the total resistance, you can inversely 1 divided by the total resistance to get the U value of the wall of of the facade. Sorry. Next. So thermal U value actually it improves wall thermal performance depending on what material you use and what insulation you use. Okay. So another one is the pitch angle of the correction factor. Next. I pass on to Shuko for the next slide. Thank you.
Thanks, Madrin. So for solar correction factor or CF, solar correction factor or CF for concentration at different rotation, example such as north, east, south or west, is the amount of solar radiation it receives. As you can see on the photo on the left, on the bottom left, the pitch of angle. Next. Okay, for ETTB formula. So for ETTB of a facade, you can see on the screen the formula to calculate the facades. And for ETTB of a building, you can refer to the right side of the legend of the calculation. Next. Okay, for example, number one, how to calculate the WWR. Okay, WWR, we get the answer 0.32. So number two, to calculate the ETTV, the answer you can see is a 49.975 watt m square. So for number three, to calculate the building overall ETV, you get the answer 48.12. So for this ETTV, it matches the requirement for BCA standard as 50 watt m square below for ETB requirement by BCA. Next, okay. So ways to reduce the ETTV. First, optimize the building orientation, like minimize east and west facades. Number two, reduce solar heat gain or lower down the CF. So for number two, reduce window to wall ratio, WWR, especially for the east and west facades. And lastly, less glassing equal to lower heat gain. Next, I'll pass to my colleague, Yvonne.
Thank you, Shukru. Next, we move on to air infiltration. Air infiltration is an uncontrolled flow of the outdoor air into the building through the opening, such as crack, gap surrounding window and door. Increased infiltration of the outdoor air will increase the sensible and lengthen heat, hence additional in the cooling load resulting in higher energy consumption. Next. The way to reduce air infiltration. Number one, to install window and door gap using a store-bought DIY paste on the sealer. Number two, proper sealing can save energy up to 15 to 20% on the monthly bill. Number three, installing an air curtain where the human traffic is high, such as entry of the shopping mall or office building. The last one, it also create a barrier between the aircon space and outdoor air. Next. Conclusion, ETTV is a key indicator of the building envelope thermal performance. It plays an important role in energy efficient building design. Proper facade design significantly reduce heat gain, essential for compliance with Singapore building standard. Next. This brings me to the end of our presentation. Thank you for your time and attention. We hope you have a better understanding of the ETTV. Thank you.
you.
Thank you.